right, so this is the screencast for objective 5, 6, and 7. We're going to cover all three of these at the same time. We're going to talk about how we can use stoichiometry to predict masses, which you guys have already learned how to go from the number of moles to grams using the molar mass. We're going to interpret a balanced chemical equation in terms of moles and construct some mole ratios. So our essential question, how are mole ratios created from a balanced equation? So what is a mole ratio? The coefficients in a balanced equation, those numbers in front, they tell us how many atoms, elements, or molecules react, but they also tell us how many moles react. It just depends on what you want it to be. It's relative to whatever you want that number to mean. You can say I have 2 atoms of this reacting, or you can say I have 2 moles of this reacting. The cool part is, since we know how to go from moles to grams, we can just figure out the mass of that formula and go from there and figure out how many grams we need. So if we take this equation right here, NH3 plus O2 yields H2O plus NO. I'm going to go ahead and make this smaller so that I can edit it. I'm going to go ahead and balance this equation. So when I balance it, I end up with 4 NH3s, and I need 5 oxygens, and I need 6 waters, and I need 4 NOs. So balancing it out, these numbers in front, they could mean atoms or they could mean moles. So how many atoms of NH3 would I need? I would need 4 to make that reaction go. I need 5 atoms of oxygen. I need 6 atoms of water, and I need 4 atoms of NO. But I could also think about it in terms of moles. So if I think in terms of moles, the same numbers apply. This could be read as 4 moles of NH3 reacts with 5 moles of oxygen, to produce 6 moles of water, and 4 moles of NO. So this reaction when balanced, these numbers in front could mean atoms or they could mean moles. And that is really useful for us. So if I said I'm going to make 4 moles of NO, well, I can take 4 moles of NO and convert that to grams and figure out how many grams of NO I'm going to make. Or if I said I'm going to make 6 moles of water, I can use the molar mass of water and convert that to grams to figure out how much water I will make. I can also figure out how many grams of NH3 and how many grams of O2 I need to make this reaction go. So it's kind of interesting that we can take just this simple thing of a mole and put it all together into changing it to grams, making it something useful. But in order to do that, I have to know how to write a mole ratio. So I'm going to show you guys just briefly here how to write a mole ratio. This is the last slide for this objective. I don't have an EduCreations video link, but I can show you in class really how to write a mole ratio. So a mole ratio, just like any other ratio, is going to be a comparison between 2 things in a chemical reaction. So I can compare chlorine to potassium iodide. So how much chlorine do I need to pass to potassium iodide? I need 1 mole of chlorine for every 2 moles of potassium iodide. So my mole ratio would be 1 to 2. I could compare potassium iodide to iodine, and my ratio would be 2 to 1. I could compare potassium iodide to potassium chloride, and my ratio would be 2 to 2. So a mole ratio is just going to be any ratio between 2 members of the reaction. It could be 2 reactants, it could be 2 products, it could be a reactant to a product, but it's always going to be between only 2 of them at a time. So like this one over here, write all the mole ratios possible. 2 moles of water is used to make 2 moles of hydrogen. Or 2 moles of water is used to make 1 mole of oxygen. So the mole ratio would be 2 to 2 or 2 to 1, depending upon what I was doing. If I wanted oxygen to water, it would be 1 mole of oxygen to 2 moles of water, so a 1 to 2 ratio. You just use the coefficients to figure out the ratios. The cool part is, once you know how to write mole ratios, these mole ratios can be used as conversion factors. And this is really doing a stoichiometry equation. you can go from moles of one substance in an equation to moles of another substance. And you can then use the mole amounts to convert to grams, which we know we can do using the molar mass, and that's very useful to us. So the next objective, objective number 9, is actually putting all of this stuff together, relating the molar mass, relating the balanced chemical reaction, and relating moles and mole ratios together. The summary for this is template number 2. Do the best that you can, just trying to answer those questions. I know they're pretty short, so there's not a whole lot to write, but do the best that you can.